explore different learning paths, different interactive simulations, and different visualizations, and whatever mathematical formula and a particular concept map and quiz. So to quickly go through all them, these are basically the features, where I mention all the features and whether it is a intermediate feature or advanced feature or how people can go ahead. This is a dummy learning path, and where people can see a beginner, intermediate stage, and the other stage, and a dummy learning progress simulator, and it can go ahead to advanced tracks also, like classical field theory, string theory basics, and research track, string quantization and all. So now coming on to the foundation, just the basic conceptual journey and the formulas of the quantum harmonic oscillator, the conceptual leaps, like basically how string comes. And next come the simulations. Simulation, we are showing classical waves and quantum waves. So classical waves, we can play the wave and we can toggle all this. We can change the amplitude, we can change the frequency, we can increase the tension, we can linear density is something that we can manage, we can have damping, and we can change the wave to a square wave, a triangle wave, a sine wave, and we can change the different animation speed and see it, and also we can see the envelope between which it is getting the oscillation. The physical insights, the basic formulas and the simulation controls and all are mentioned here. The same goes for the quantum oscillators, so we can just play the oscillator and we can check the different animation speed and different wave functions and the different probability scales and all, and these are the things that we can see here. Also the different concepts and the simulation controls and the learning objectives. In the visualization lab, this is a 3D visualization basically, where we can see a vibrating string, and we can see, we can zoom in, zoom out, all the visualization guides are mentioned here. We can increase the string tension, we can increase the frequency, and if we see it from the 2D, it will look like a sine wave. Calabi manifolds, these are all the manifolds. We can change the complexity, and these are all the extra dimension. We can zoom in, we can zoom out, we can download, and this is a correspondence where the holographic duality between gravity and the boundary field theory is mentioned here, and this is the physics insights and all. And here all the basic mathematical details are mentioned, whatever people need to know, like Virasoro algebra, extra dimension, compactification. And this is a concept map where people can click on the nodes to see the detailed information. They can drag along their mouse wheel to zoom in and zoom out. Specific concepts, you can click on a concept, and connected concepts it will show. So that is basically the submission. Thank you.